Oh my word, we're already on a bug. Hello, everyone. All right, we got people here. PJ, good night. We'll see you later, maybe next week, we hope. Logan, Bumblebee, Bored, Lil Moped, Rockers Boxers, Cat Got Your Keyboard, Tired Eyes, Wixley, hello. Donkus, hello. Echo, Potato Queen, Pawtail, not really, it's Ed, sorry. The Mouse, Dan Man, A Thoron. It's Katie, my dudes. Hello, everyone. How are we doing this evening? Edit Mars, it's your first time catching one of these. Well, that's very exciting. Welcome. So, tonight, the way these work, if you haven't seen any of the YouTube videos of them, we kind of pan around on the pasture and see what we can find. We started off strong here tonight with this very slow, but still going, scarab beetle. And this is an aphodiine dung beetle. So there are actually two different subfamilies of scarab beetle that have independently evolved to feed on dung resources. You have your normal dung beetles, the scarabeines. Those are like the ones you think about with like Egyptian imagery and things like that, which are like your standard dung beetles. And then you have your aphodiines, which are the little dung beetles. Most of them are like less than 8 millimeters long, which is half an inch, maybe. And a lot of them are much, much smaller than that. And we've talked about dung beetle guilds before, about how they actually interact with the environment. And these ones are the dwellers. These are the ones that actually live in the dung. Oh, we got a raid tonight, everyone. Orofia, thank you, thank you. 76 viewers coming in. Welcome to all the raiders to Bug Hunt Chat Chats. I was just explaining here our dung beetle friend who maybe has seen better days. It is 39 degrees Fahrenheit, 4 degrees Celsius here at Alveus. So it is a little bit chilly for these guys to be out wandering around. As we've seen in the past few weeks, we've been seeing fewer and fewer insects active on the cameras. And that's to be a little bit expected when we start getting temperatures down this low. But this guy seems to be having some better luck than our beetle friend that we had last week, who unfortunately was upside down for the entirety of the stream. Big McClargy, good to see you. How's it going tonight? Darkchild 99, it happens. Yeah, we get lots of bugs on their backs. But yeah, I think he's fine. He's just cold. You know, they definitely slow down when it's not quite as warm. So, how's everyone doing tonight? Are there any pressing bug questions before I go into some stuff that was asked in the Discord 2 weeks ago that I Am I back? Okay, great. You can hear me. Yeah, so I saw someone ask in the very brief period of offline chat if Dr. Allison would be joining us tonight. And originally, that was the plan. However, the power grid in the state of Georgia has apparently decided to play some tricks on us tonight. And Allison won't be able to make it this week, unfortunately. It is not super well boding when my computer also decides to randomly shut off. But hopefully that won't happen again this evening. You guys all will have Dr. Allison next week, however, because at the time of Chat's recording, I should be on an airplane flying back home for the holidays. So she should be around next week, pending any further power disasters on her end. Okay, let's see. What did I miss? If you're cold, they're cold, bring them inside. So true. Yeah, Meg Jake. Put a beetle I found in my apartment outside. Is that the right thing to do? Yeah, I mean, you're not likely wanting to coexist with said beetle, and that's fine. Not everybody is ready for that. And yeah, I mean, they came in from outside most likely anyway, so there's no reason that it shouldn't be able to survive outside. Now, granted, it is getting colder here in certain parts of the US, and so that might not be super great for it, but it is still probably the correct decision. I feel like you'll be forcing the family to watch bug hunts with me. Well, that's fun. Next time when you go back, say hi to Luke for me. I saw him at the bug conference a couple weeks ago, and obviously wasn't going to bring up that I knew one of his students from online, but if you do see him, tell him I say hi. So this fly here is actually kind of interesting before we back too far off of it. This is probably one of the culprits that we see bothering Ace and Winnie. That looked like a stable fly to me. They're called stable flies because they tend to hang out in horse stables. But it is actually the same group of flies as your typical housefly, muscidae or mussidae, Muscidae. And they're a type of muscid. I forget what the common name for those are, but they're muscids that have modified mouth parts for piercing and feeding on blood, sort of like mosquitoes, but not quite as intricate. But that was very likely one of the flies that we see that bother Winnie, which is no good because precious baby cow. So, as I said before, I did have somebody ask a question in the bug Discord. Someone plugged the bug cord for me while we're doing this. That I thought was a really good and a really interesting question. And there are some, as there always are, cool fun facts about it that I can tell you about. Somebody was trying to make a trivia question or something. I forget what actually inspired this. But they had asked about other sorts of detritivores besides the ones that we commonly talk about here at Alveus, things like the cockroaches and the isopods mainly. Those are like our two big ambassadors, and Hank, of course, the millipede. Those are our big ambassadors for like bugs being super important to break down detritus and decaying material like leaves and wood and logs and stuff like that in the environment. And we often talk about them in terms of nature's cleanup crew, or nature's little janitors, whatever you want to think of them as. And someone asked if there were any groups of arachnids that functioned in a similar capacity. Oh, MG, you're here. Okay. Yeah, trivia question for work. I thought that's what it was. And yes, Donkus, exactly, the springtails, pixels, as we've been calling them here. But yeah, MG asked specifically if there were any arachnid detritivores. And that's a really fun question, because arachnids as a whole are some of the, percentage-wise, the most carnivorous things we have on this planet. There are detritivores in mites. Lots and lots of mites out there are helping to break things down. The little mites that we have on the Barbaras and stuff in the colony here, in nature, would be helping them break down the leaf material and stuff that they live in. So those are a really, really good example of an arachnid that fulfills that role of helping to kind of clean up the rotting and decaying stuff in the environment. But then we also have the harvestmen, the Apilionids, the daddy longlegs, if you should call them that, that we see hanging around the wolf dens and stuff like that. There are some in that group that are predatory and will feed on other invertebrates, other arthropods, things like that. But then there's another group of them that are feeding on mold spores and feeding on mold and fungus and dead and decaying leaves. Ophelia, that is a great question. I have that specifically in my notes for this episode. So jumping ahead just a tiny bit, Ophelia brought up our eyebrow eyelash mites. And some of you might be thinking, what the hell is he talking about? Well, we have these things called Demodex mites that live in the hair follicles of mammals. In humans particularly, they like our eyebrows and they like our eyelashes, but there is a species of Demodex mite that you can find on dogs, and I think there are some that are in actually several other mammalian lineages as well. Demodex mites are really, really cool. Please do not panic. I promise they are not bad. It is not like, it's not like scabies or anything. It's not a disease. A lot of people have these. They are able to crawl out of your hair follicles, and they move at about 8 millimeters an hour is what I read, I think, in that Wikipedia article that I just linked, which is not very fast and not very far at all. But they don't need to be going very far, because they're just trying to travel between different, hair follicles on your face. And they're not something that we're born with. They are transmitted from person to person, which is called horizontal transmission. We usually think of that in terms of gene flow and things like that in an evolutionary biology capacity. But that just means that you get your eyebrow mites from someone else. They are less common in toddlers than they are in the elderly. And that is simply because the elderly have had more time to make that run-in with somebody that has them. It can be, through a hug or a kiss or whatever. Any sort of touching of the face can actually transmit the mites from person to person. And again, it's not bad. These mites do help clean out your hair follicles. They do eat the little debris and oils and things like that that you have on your face. And the really nice thing is that they don't get rid of any of it. People think about this a lot, and they don't actually defecate. They just retain all of their nutrients that they've taken in throughout their entire life, and then when they die, they do end up falling out of the hair follicles. So they take all of their waste with them, which is very nice. But yes, Demodex mites are pretty cool and are definitely a form of detritivores. it's not the traditional sense that you would expect in terms of like breaking down forest leaf litter, but they fit the definitions of helping to kind of clean up and get rid of some of that unnecessary organic material. And this just happens to be on your face. Silvera, yes, mites for now, but we're going to transition to spiders here in just a second. Allergic dust mites are my eyebrow buddies making me itchy. I don't think so. I don't think they're correlated, but casual, I honestly don't know for sure. Everybody poops this mite erasure. So, anyway, sorry, had to regain my thoughts there of where we were going next. So we've talked about Demodex mites now, but going back to the thing that I said at the beginning about arachnids being the largest percentage-wise carnivorous group of anything on the planet, specifically that refers to spiders. So Arainae is the order for all of the different spiders. That's everything from jumping spiders to orb weavers to tarantulas. And that group has something like 44,000 species worldwide. So there are about 44,000 different species of spider worldwide, and the largest, most diverse group of that is actually the jumping spiders. So there are more types of jumping spiders than any other spiders on the planet, which I think is pretty cool. We love jumping spiders here on this stream. But tying the largely carnivorous, of those like 44,000 spiders, we are aware of just one that is primarily herbivorous. So herbivory is obviously eating plants. You think about, Winnie and the donkeys and Ace. Those are all herbivores, right? They eat all the hay and they eat all the grain that we donate through the Feed. But arachnids and spiders in particular are very, very highly carnivorous. They are the largest group of what we thought were solely carnivorous organisms on the planet. That was until 2010 when this paper described the herbivorous dietary preferences of a jumping spider in Central and South America called Bagheera kiplingi. Now, those might sound familiar to you. Bagheera is the name of the Black Panther in the children's story The Jungle Book, and then Rudyard Kipling was the author of The Jungle Book. So Bagheera kiplingi was named specifically after that character in that novel, and this spider was named way back in 1896. So we've known about this spider for a very, very long time. And our original description of this spider was only known from the male. So this happens a lot in biology where you're out in the field, you find an organism, you bring it back, and you only have a male. And a lot of the time, some of the diagnostic characters are only on the male anyway. So there are lots and lots of species out there that were originally, or still, only described from male specimens. And that's obviously a really huge disservice. People are starting to look more now at female reproductive anatomy and things like that to make species descriptions more inclusive and kind of more complete, because if you're missing what is essentially half of the population, that's no good, right? Obviously, we want the full, complete picture. And we've talked about type specimens before, how the holotype is like the initial individual that a species was described from. There is actually a specific term for the original specimen of the opposite sex once we know what that opposite sex is. So if you had a male that you were initially describing from just the male, and then we figured out what the females were, that female would be called the allotype. Allotype. But it goes the same way. If we describe something initially from just a female specimen, the allotype then would be the male. And this is just something notable. Like I said, the male of Bagheera kiplingi was originally described in 1896, and then exactly 100 years later, a guy named Wayne Madison described the female. Pretty cool stuff. It's a really interesting, really pretty looking spider. I have the Wikipedia link in chat, sending it again right now. And as you're all saying, misogyny in the bug world is crazy. The Wikipedia page does only have the picture of the male. Oh, hello. That's a big bug. But anyway, getting back on track into Bagheera kiplingi and why we're talking about this. In 2010, there was a paper published, and it was really, really huge news at the time because, like I said, there are no other spiders that we know of that are primarily herbivorous. And this paper in 2010 was suggesting that, like, up to 80% of the time, these things are preferentially feeding on Beltian bodies, which are little structures on acacia plants specifically that are there to attract ants for this other really cool mutualism that happens between ants and acacias, and we can talk about that in just a second. But these spiders are there preferentially feeding on these Beltian bodies and not the ants. They will Beltian. There we go. Beltian bodies, like that. Not Belgian, not quite like the waffle, but Beltian, named after some dude, I'm pretty sure. And so, yeah, these really cool spiders are preferentially feeding, like 80% of their diet are these little bundles that the tree makes specifically for ants. But this spider is taking it over, and they are actually competing with the ants for access to these specific bodies on the acacia trees. Now, Beltian bodies is specific to acacia trees. If you have a little starchy, sweet packet of food on your seed specifically for ants, evolutionarily, that's called an elaiosome. Elaiosome. And Beltian bodies are just a specialized version of an elaiosome that specifically refers to acacia plants. Now, Ophelia, again, jumping ahead, talking about the ant trees. So acacias are notable because they have a very, very cool mutualistic relationship with ants. Now, we've seen ants on this stream many, many, many times before, and we've seen how brutal that can be with some of our poor beetle buddies that get torn apart by the fire ants and stuff that we have here in the pasture. And so, as you can imagine from that, there's a lot of stuff in nature that just does not want to mess around with ants. Ants are colonial organisms, so we've talked about that before, and they're really interesting social structures. So when there's one ant, there are generally a lot of ants. And as we saw on the Arizona streams, poor Allison, poor Maya, the ants can sting, and the ants can bite. And it's not very pleasant. It actually hurts quite a bit. And so if you are a small organism, like another bug, you generally try to stay out of the way of ants. If you are a small frog or lizard or even small mammal, and you get caught in an army ant bivouac or an army ant swarm down in Central and South America, they don't care. They'll pull you apart. And so these acacia trees are quite spiky, so they do have some defenses on their own to prevent things from eating them. But they produce these little Beltian bodies specifically to make the ants hang out, because the ants prevent other insects from coming and preying on the seeds of the acacia tree. And the ants, in turn, get protection from some of the larger predators, so things like, elephants and giraffes and some of these Australian things that are feeding on acacias. They get turned away by the spikes on the plant. But for the smaller predators, the ants are actually what keep them away. And so, in reward for helping to protect the seeds of the acacia, they give them not only these little Beltian bodies to feed on and help sustain the colony, but they also provide domatia, which is another ant acacia specific term, domatia. And that is like a little hollowed out cavity in the base of the thorn of the acacia, which the ants can live inside of. So these trees are basically doing everything they can to make the acacia tree attractive to have ants living in there, because those ants provide a sort of service to the acacia tree. And all of this is wrapping back around to, they've done all of this work to have ants help kind of protect them from certain other insects and other invertebrates. But now you have this spider. You have Bagheera kiplingi coming and eating these Beltian bodies that were meant for the ants. But this spider has co-opted that, and up preferentially like 80% of its diet is these Beltian bodies. We see that when they're not available, they will resort to eating kind of normal spider food, like other invertebrates. They'll even sometimes eat each other, which is no bueno. But it's this really, really cool system where a almost entirely, as far as we know, carnivorous lineage of spiders has made the switch at least one time to a mostly herbivorous diet, and I think that's really, really, really cool. The elaiosomes on other plant seeds are also specifically targeted for ants, and it's a really kind of fatty, lipid-rich, really food-rich resource that forms on the end of the seed, and again, it's specifically used as a reward for ants. And so another one of the things that ants do really well, and if you've seen the incredibly accurate Disney Pixar movie A Bug's Life, ants collect seeds. There are a lot of ants that specifically harvest seeds to feed on. And those are maybe not as good for the plants, because those ones are specifically preying upon the seeds. Those ants eat the seeds of those plants. But if you're a plant that has an elaisome, you have this starchy, sugary reward on the backside of your seed, but the ant is not interested in actually eating your seed. What does that mean? Where does that ant take that seed? Waiting. Katie and my dudes, yes. It is free planting. That is exactly what happens. So aliosomes are there to attract ants to your seeds. They will then take those seeds down into their nest underground, and they will eat the little sugary bit off the end of the seed, but they won't actually attack the seed itself. And what they've now done is they have taken a seed underground, usually pretty far away from the parent plant. There's this whole system of risk and reward of like where you disperse your seeds, and fruit on any plant. So like all the fruits that we eat, the reason why plants put a lot of energy into making fruit is to make their seed attractive to an herbivore of some sort that will then eat the seed, go many, many miles away in similar habitats, and then poop it out. Fruit is a way that evolution has convinced herbivores to move those seeds away from the parent plant, so you're not competing directly for the same resources as your offspring. And so one way to do it is to get a large herbivore, or birds do it too. Birds do it a lot. To feed on your berries or to feed on your seeds. They'll digest it, they'll poop out your seeds way further on down the line, and then these things get planted. But if you're able to work it on like a smaller scale where you don't need it to disperse quite as far, you can do ants. It's called myrmecochory, which comes from myrmeco is like the Latin prefix talking about ants, and then chory actually comes from some sort of reference to a dance, I believe. And so those aliosomes, those little fatty bits on the end of the seeds, are attractive to the ants. The ants will take them down into the nest, feed on that aliosome, feed on the part that the plant wants you to feed on, and then leave the seeds in a refuse pile, basically. A lot of ants will have a chamber or a part of their tunnel system that is basically just a garbage dump. They will take all of the things that they don't want to eat, store it down there, keeps the rest of the colony nice and clean. But what it also does is it makes a cool seed bank. So all those seeds that they didn't eat get stored and piled up. And after a good rain, once it soaks the ground down into those seeds, they can start to germinate. And then you have plants popping up in places pretty far away from where the parent plant was, all because that seed was able to be transported by ants. And I think that's so cool. Lots of stuff relies on ants because their social structures and their colonial living and like all the stuff that ants do is so cool. And additionally, like I was talking about earlier, there are lots of things that kind of avoid ants on purpose. And that has also led to this whole other radiation of insects across different orders, like completely unrelated things like plant hoppers. There are moths, there are even some jumping spiders that will mimic ants, all to get the protection of what it is to like be an ant, right? You're supposed to have all these other ants around that can sting and bite and help protect you. So if you get even just a little bit of that, you have a non-dangerous mimic. Like if you're a plant hopper, for instance, you don't have the same sort of backup that you get if you're actually an ant. But if you look like an ant, predators aren't going to want to mess with you, like just in case, right? They've learned their lesson and they're ingrained to stay away from ants. This is like a dangerous system. And if you get a little bit of benefit from that, it works out really, really well for you. So this also happens with aposematic coloration. Thinking about insects that sting, the first thing that probably comes to mind is bees and wasps, right? You see that black and yellow coloration, and you initially you have the thought of like, oh man, that might be able to sting me. And there are lots of flies and other insects that will kind of co-opt that black and yellow color system as aposematic coloration, this warning system, to be able to get some of that protection that's afforded to things where they go, oh, that could sting. I just saw someone pop up with that merch purchasing, and I believe it was their friend Eli. So Eli, happy birthday. You've got a good friend there buying Alveus merch. And also tuning into bug hunts. Very, very fun. Ophelia, Bugs Life themed area in Disney with giant clovers for shade. Yes. And they're getting rid of It's Tough to Be a Bug. I haven't been to Disney in a very, very long time. But when I was in college in Florida, we got to do some cool behind the scenes stuff at Animal Kingdom, like with their insect keepers and stuff like that. So we did get, obviously get to see It's Tough to Be a Bug at that point, which was very cool. And they're getting rid of it, which is quite sad. James makes cakes. Good to see you, man. Haven't seen you in chat in a while. Hope everything's going okay. Katie, my dudes, asked, difference between colonial living and being a superorganism. I've heard ants referred to as both. That's a cool question. So insects in general, they have different levels of sociality. The three things that you need to have a eusocial insect, EU social, which means truly social, like it is the definition of sociality in insects, is you need three things. Overlapping generations, so you have multiple different ages of organism kind of in the same colony. Reproductive division of labor, which means that there is a caste system of some sort, like there are different jobs for different members of the colony. Think with ants, you have soldiers, you've got workers, you've got the queen, you've got like nurse ants that specifically take care of the other ants. And then the third thing that you need is cooperative brood care, which means that there are organisms in the colony taking care of offspring that are not their own. In ant colonies, there is one queen laying eggs. All of the workers, so the vast majority of ants in that colony, are all going to be offspring of that one queen. And so they help raise essentially what are their younger siblings. And so ants and honeybees and termites and some paper wasps will all fill those three categories of eusociality. Those truly social fit all three categories. But then you have things like Cryptocercus, which are the wood-feeding cockroaches that aren't quite evolved far enough to be termites yet. They're like that cool cross-linkage between cockroaches and termites. You've got things like angel insects or zoopterans that will live in groups. You have best beetles, and you have things that will live like kind of near each other, and they will maybe kind of communicate, and maybe they'll have one or two or in different combinations of those three things you need for eusociality, but they won't have all three. So ants definitely live colonially. That is for sure. That is not up for debate. The idea of the superorganism comes from two guys named Bert Holdobler and E.O. Wilson, who are like ant gods. A lot of the really kind of fundamental understandings that we have of how ant, for lack of a better word, society works comes from research that they have done over the past many, many decades. They have a book that they wrote together called The Superorganism, which is a fantastic read. And the idea of the superorganism is that you have all of these moving parts, all of these worker ants that are working together towards a common goal, and that common goal is the success of the colony. So the best way to think about this, or a good way that I've kind of worked out to think about this, is like, you are made up, like you physically as a person are made up of cells, and your cells are doing the majority of the work, right? They're the ones that are moving things through your body, getting nutrients where it needs to go, filtering out the bad stuff. And those cells are doing things for the greater good of you as a person. The superorganism theory when it comes to ants is that the ant, like the individual ant that you see crawling around, is not so much concerned with its own personal survival, but it is simply a player in the larger part of the organism that is the colony, right? So that might sound like kind of hand wavy madman ramblings, and I totally get where you're coming from, but I can get us there, I promise. When ant colonies reproduce, they reproduce at the colony level. So in an ant colony, you have one queen ant who will be in charge of that colony. She is the most important head figure of that colony for like upwards of 10, 15, sometimes 20 or 30 years. Queen ants can live an incredibly long time. And the really cool thing about that is they only mate one time. She mates with sometimes multiple males as she is leaving the colony that she was initially born into. And then for the next 20 plus years, she stores and very selectively uses that sperm to help build the colony. In insect systems, a lot of the times, female queens can lay unfertilized eggs. And those unfertilized eggs become male ants. But then when you fertilize the egg, it becomes a female ant. So she does need to mate in order to produce other female ants. And so for her first winter, she will lay a couple of eggs. They will overwinter together. She will tend to them. And then in the spring, they'll hatch. And she will now have a little group of maybe 5 to 20 workers now in her colony that are all of her daughters. That lets her focus on reproduction, laying more eggs, and now all of those other workers that she has just birthed can help with defending the colony, going to find food, excavating tunnels, all of that stuff. And this cycle just repeats. So she has an initial set of workers, and then they help build up the colony a little bit. She lays more eggs, and now she has helpers to help raise those. Remember, cooperative brood care and overlapping generations are two of the three things that you need to be a truly social insect. And so what that means is that in an ant colony, only the queen is reproducing, ever. All of those worker ants and like every ant that you see out in the world is going to be a daughter of a central queen in that ant colony. But there is a time when the colony gets too big. You have ants that are dying off because the non-queen ants don't live for 20 years. So, yes, Katie, exactly. We're getting there. So when the colony gets too big and like you're starting to produce too many workers, that, oh, okay, we're starting to get food limited where we are currently. What happens then, like I said, is what Katie just posted in the chat, are these nuptial swarms or nuptial flights. And what happens there is the queen will lay male and female eggs. They will feed them a special concoction with different hormones in them that make those particular ants grow wings. And those are called alates, A-L-A-T-E-S. And that is just the winged form of an ant. So then, like I said, this is on the colony level. When the colony gets too big, they produce these alates. They go out, and this happens around the same time for different species every year. Like all of the all of the colonies of the same species will have their nuptial flights at around the same time in the same area. So what that means is that they don't have to mate with their brothers, which is great. Try to avoid that at all costs. You have these nuptial flights where winged females will go out and mate with males of other colonies. And this is oftentimes based on temperature or relative humidity or rain days. There are a lot of different sorts of cues that can kind of trigger when this happens, but a lot of the time it has to do with temperature and humidity, where they kind of synchronize up based on larger environmental conditions. And then they will go out, and all of these different ants from all of these different colonies will mate together, and then the queens will go off and start their own colonies. Amanda, hello. We're learning about ant reproduction. And so all of these colonies are reproducing at the same time, and these individuals will come from their home colonies, mate, go off and find a suitable location for their own colony, and the whole system starts over again. So then you go back to having just the one queen laying a few eggs, overwintering, getting that first group of children to help her raise more children in the future. And that's how you get ant colony reproduction. And that's this whole idea of the superorganism in a nutshell, is that individual ants, like an individual ant in the colony, isn't doing anything to pass on its own genetics, because they can't. Your average female ant cannot reproduce, and the whole goal, like evolutionarily on any sort of scale, is just to pass on your genetics. And so rather than being focused on it individually, you're focused on getting to the point where you can reproduce as a colony. And that's where that idea of the superorganism comes in, because the individual organism of that individual ant is not the thing that selection and natural selection and predation and everything is working on. It's working on the colony as a whole. And so just like the cells in your body are doing things to help keep you alive and maximize your impact and maximize your fitness, the individual ant is like the individual cell in the colony, where its whole thing is trying to keep the colony healthy, trying to keep the colony at a certain step where it's able to reproduce. And I think that's really cool. I think ants are really neat. I worked at an ant lab for 2 years as an undergrad, and it was super cool. I still think ants are super fascinating. I actually have that Super Colony book signed by Bert Holdobler. He was a professor at my institution for a while, so I have had the fortunes to meet him and get him to sign my cool ant book. Definitely nerd out about that a little bit, which is really, really cool. So that is Stolen 87. It's 4 a.m. for you. Well, we're going to wrap up here in about 10 minutes, and hopefully you'll be able to get back to sleep. But let me scroll back, see what I missed during my ant monologue. Oh, Ophelia, you're going to Animal Kingdom. That's great. Yeah. Definitely post that in the bug Discord for us for posterity's sake. Nuclear Snake, welcome. Yes, you're here too. Still catching up, still catching up. Potato Queen, yes. Impressive lifespan. I'm assuming you're talking about the queen ants. Yeah, they live for a very, very, very long time. And when the queen passes on, generally that is the end of the colony. The normal ants will continue on with their jobs day to day, but there's no more reproduction, so it just kind of fizzles out after a while. And that's the reason that, like, ant farms that you can buy on Amazon don't last forever. Because when you buy those ants, you're only buying workers, and so they never reproduce, so you're never going to continue to have, like, more ants to fill that role. There is a whole ant keeping community where you do have queens and workers and larvae and, like, this whole complex cycle, but it's definitely a lot more complex than putting sand in that really skinny tank that you get, like, from science suppliers online. So that is definitely something you can do, but it's a lot more in depth than most people think than just from your normal ant farms. Olympic National Park, nuptial swarm isn't coming with the big black carpenter ants. Yes. So it happens with ants, and it also happens with termites. So they will both do the same sort of reproduction at the colonial level. And you get those big nuptial flights where you have different ants and different termites and stuff flying around. Quokka, hello. Yes. Last 10 minutes we caught up. We're talking about ant reproduction this time. Oh, Katie, leafcutter ants for the first time. So cool. I haven't seen the actual, like, ATA leafcutters doing their little ant trail in the wild. But we do have lots of harvester ants out here in Arizona, which will basically clear cut a mound. I know we showed what the mounds look like during the in-person bug stream, like way back in July when I first met you guys. I know we showed some of that harvester ant, but they clear this really big, like, dirt area around their colony entrance, and they basically just take down all of the plants in that area, take all the seeds, and then they move out radially trying to collect all their other seeds and take them down. And those are the kinds of ants that actually are eating the seeds, not the ones that are simply trying to help plant the seeds. Yes, Ants Canada. He was definitely my introduction to that as well. That whole hobby, yeah. But there's there's a thing that one of my friends runs called the Ant Network, I believe. That has also done a couple of really good videos on starter ant keeping things, and not quite as over the top as the stuff that Ants Canada does with, like, his really big paludarium displays and stuff like that. It doesn't have to be this multiple 1,000-gallon tank that you keep your ants in. You can definitely keep them in much more reasonable accommodations. Panama vacation for ziplining. God, that's so cool. Very, very jealous. Okay, I think I'm caught up. Does anyone else have any pressing bug questions for this week? I've exhausted my list of speaking topics that we got from the bug Discord a couple weeks ago. Yes? No? Maybe? Oh, stolen. Yeah, of course. Happy to. We enjoy doing bug hunts. We enjoy doing chats. Because this gives Allison and I just a chance to nerd out about how cool bugs are. This was our whole degree. You know, we spend a lot of time doing this sort of stuff, and having stuff like this. I know not everyone in chat is like going to go off and become an entomologist, but like I said last time, just having people that appreciate bugs just a little bit more, we love seeing that. I saw someone actually post earlier that it's cool to learn about bugs as an adult, and you're absolutely right. Okay, couple of questions. We should be good now to round this out for the last couple minutes. Katie, how do all the ants know to fly at the same time? I think I touched on that a little bit earlier. It's largely environmental cues. A lot of insects operate off of what we call degree days, which is a certain amount of time in a row, like cumulatively, of degrees above a certain temperature. And the reason it needs to be a series or a period of time above a certain temperature is like we can have really odd warm days in the middle of winter. And then if they would all come out on that first warm day, the next hard freeze is going to set them back a very, very long time. So cumulatively, they need to be above a certain temperature for a certain amount of time, and then they will trigger with like the first rain. It has a lot to do with temperature. It has a lot to do with relative humidity, I think. It's not on a calendar basis, even though like it might happen at the end of April or wherever you are. It might happen around the same time of year every year. It's not because they're like, oh, it's April 15th, I gotta bounce. It's because those environmental conditions tend to occur around that same time every year. And yeah, that is a big thing that we're looking at in response to climate change, is seeing these things emerge earlier and earlier, and they're starting to get off balance with their food sources or their food plants. And so there's a really huge opportunity for research in that area of like seeing how global warming and climate change is contributing to shifts in behavioral conditions for insects and for all matter of animals to begin with. Roxas Boxers, my favorite example of convergent evolution in bugs if I have one. I've never thought about it specifically, but when I was in Thailand this summer, we had these big, hairy paper wasps coming into the light sheet. So we had the big bright light up, obviously, to look for bugs. And there were these big, kind of brownish red wasps that would come in. And then one of the nights, I was moving them around with my big, foot-long pair of forceps so I wouldn't get stung. And all of a sudden, one turns around and starts grabbing at me with little tiny arms. And it was a mantis fly. So I think we've seen those on chat before, but they're not praying mantids. They're actually closer related to lacewings. But they have converged on... I was answering your question wrong. Yeah, I guess we'll stick with that, though. So mantid flies are these things that are completely unrelated to praying mantids, but they've still converged on that, like, raptorial forearm, long pronotum, like, body shape and method of grabbing their prey. So I would say that the mantid and mantid fly kind of convergence on that thing is very, very cool. What I was talking about was mimicry again. Like we were talking about earlier, you have those flies that will imitate bees a lot of the time because of the protection that they get from mimicking something that can sting. These this mantis fly that I was talking about in Thailand had that same sort of protection from being in the same area as these wasps that it looked very, very, very similar to. How many fire ants would it take to carry a whole person across an ocean? I have no idea, Ophelia. That is a crazy question, and I bet somebody could math it out, but I'm not going to be that person. Smiley of day. Oh, yeah, I saw that. Your huge swarm of ladybugs. Those were Hippodamia convergens, I think. Those are a very well-known species that are known to congregate like that. Donkus, keep trying. We would love to see your aloe spider. Shinybot, he fell over. The question was, why is this bug on his back? It's a little bit lethargic. It's dropped 4 degrees in temperature since we started this, so it's a little bit cool. They're not quite as agile when it gets cold out, so he, I'm pretty sure, tripped over that big stick right next to him, and is going to have some trouble righting himself. But the nice thing is this is not really detrimental to him. Once it warms up in the morning and he gets some sun on him, he should be able to right himself up and fly away. Really cool scorpion beetle and caterpillar mimic jumping spiders. Yeah, cricket. There are lots of things that will sort of go in that group, and you see really interesting patterns with that too. Like, of course, there are lots of things that will mimic ants, but there's also a species of moth that has what looks like fruit flies on its wings, and like I'm not really sure how that's super beneficial to it. But you'll also get things that will mimic spiders and kind of these really interesting cross taxa mimicry rings, which is actually really, really neat. Oh, Amanda, yeah, if you do flip him over, please take a picture and send it to us tomorrow if he's still there. But hopefully not. Logan, could you zoom out so we can see where this guy is for Amanda in the morning? And then we can close her down for the night. Thank you, Logan. Oh, he's in the danger zone. He's in the danger zone in the morning if Ace or Winnie gets a hold of the feeder at some point tonight. But yeah, so he's down there right in front of the feeder, Amanda. If you do get him in the morning, please take a picture. Thank you very much, everyone. I think that's it for me tonight. I appreciate you all again for being here for bug hunts, for chats, for letting me rant about ants this evening, but for in general letting me info dump on you every couple of weeks. And as always, everyone, please thank Logan for driving us around. We appreciate your hard work as always, even if the bugs are not super cooperative because it's starting to get chilly. All right, everyone, have a good night, and pop into the bug Discord if you have any questions throughout the week. And unless the power grid says no again, next week should be Allison. Thank you all and have a good night.